So first of all, thank you so much. Pleasure to be here with you. Thank you to Consulting and Co for inviting us to share here our passion and our job. That is something that we actually make jokes about between entrepreneurs. If you don't find the perfect job, you just create it, right? So this is more or less what the kind of things that we do. So I'm Juan Peña. I am the CEO of Orbital EOS, and we are a Spanish company using satellites to solve problems on Earth. So we use space technology in order to answer questions about what is happening on Earth. Well, the best way to describe where I think it's to tell the story of our company. So in the past, everything started here. We had the chance to work for the Spanish Coast Guard for 12 years on board this aircraft. This aircraft had two main roles: marine pollution monitoring, so detect oil spills at sea and characterize them and identify the source. And also we performed search and rescue operations, so detect ships at sea that are in danger, right, and try to save lives at sea. So during these 12 years that we had the opportunity to work for the Spanish Coast Guard, this is a summary of the activities that we had the luck to do. Traffic control, oil spill monitoring, search and rescue, customs as well. Here you can see a picture from inside the aircraft. So this guy is me some years ago. Behind me it's Pablo. We are both the co-founders of the company. So actually what we try to do is to integrate information from a lot of sensors that were in the aircraft and try to understand what was happening at the surface of the ocean using all those sensors. About marine pollution, for the people who is not really familiar with the problem, I would say that there are three main sources of oil pollution at sea. One would be leaks from offshore facilities. The second one would be illegal discharges of oily waste from ships, something that unfortunately is very common practice. And the third one would be accidents, major accidents. The source that maybe you're more familiar with. But anecdotally, accidents only count for around 10% of the oil that is annually ending up at the ocean. So in geographical terms, this problem is so challenging because it's a problem of big data, right? We are dealing with a fleet, a global fleet of around 95,000 ships in the world, and 1.4 thousand oil rigs in world's oceans. At the same time, the oceans cover an area that is around 2.5 times the area covered by continents. And according to United Nations Environmental Program, every year around 2 million tons of oil end up at the ocean. And more importantly, most of that goes totally undetected. So we started to reflect with our experience working for the Coast Guard, how can we better understand this problem on a global scale? And how can we use space technology, satellites, to help us address this issue, to help us, first of all, understand what is happening, understand the size of the problem, and then going forward, how to address it. So as you may guess, the challenge is huge in terms of collection, processing, and analysis of data. Currently, we have many satellites, but we have to downlink the images of the satellites. We're talking about petabytes of data, and we have to process all this data and analyze all this data in a very short time and on a global scale. So I will tell a little bit about the present. That was the past, our reflections about the problem and trying to frame the problem. So that is what we actually do now. We use constellations of satellites, mainly from the European Space Agency and from NASA, in order to monitor the oceans of the globe on a daily basis. Here you can see two different satellites that we use. Mainly the difference wouldn't be so much in the platform itself. Well, at the end, the satellite, it's orbiting the Earth, right? And giving, taking images, scanning the Earth. The difference is more related to the sensor that we are using. On the right, on the left-hand side, you have what we call a radar satellite. It's an active sensor, meaning that it sends a signal to the Earth and then reads the energy that comes back, right? So it's a ratio. What we're seeing, it's a ratio between the energy that we are sending to the Earth and what comes back. On the right-hand side, you have what we call an optical satellite. An optical satellite, it's a very, let's say, complex camera that takes photographs of the Earth, pictures of the Earth, with the colors that the human eye is not able to see. So main difference between these two technologies, radar sensors can see during the night, for instance, and can see through the clouds. So they are weather independent. That is very interesting for some kind of applications because we can detect ships, for instance, or oil spills during the night. With optical sensors, optical satellites, we cannot see during the night and we cannot see through the clouds, but they give us the opportunity to characterize what we see. So this is an example of how these satellites see the city of Jeddah in Saudi Arabia. On the left-hand side, you have a radar satellite. As I said, the picture is telling us how the objects of the Earth reflect the energy that the satellite is sending, right? So for instance, if you see very white pixels, that means that there are buildings with irregular shapes and normally with a lot of angular structures that make the energy reflect in many directions. When we see colors in gray, in dark gray or in black, that means that the surface tends to be very smooth, like you can see in the sea. On the right-hand side, you see the image of an optical satellite that is very familiar because it's like a picture of the Earth, right? We can see colors in RGB in the same way as a human eye works. So as an observation platform, a satellite is very, very interesting comparing to other platforms like drones or aircraft. There are three main advantages that we have identified. First of all, they see the big picture. They have a privileged vision of what is happening. They do not rest at all. They work 24 hours a day while they are alive on the space. That would be around 7 years, according to European Space Agency standards. And another very interesting advantage is that they transcend every human boundary. So we can monitor every part of the world. It's not the case, for instance, when you are using an aircraft, because you have restrictions in the airspace. So as you could see in the picture, in the video, sorry, only with 2 satellites, we can scan the whole Earth in just 5 days. So putting all in perspective, after all these years in the Coast Guard and after leveraging all the background and understanding the technology of satellites and the advantages, we found ourselves our mission, and our mission is to democratize the access to maritime intelligence using satellite observation. In order to do that, we have designed a product, a digital platform, which is called EOS Viewer, that provides automatic monitoring of oil spills at global scale. In order to do that, we use satellite observation and artificial intelligence. We aim at achieving a full automation of the supply chain that translates into a product that is very fast, highly scalable, and almost autonomous. So it doesn't need a lot of human intervention. Some milestones that we have achieved in our story, in our career. This solution has been recently awarded by the European Space Agency. We're very, very proud of that, because European Space Agency is a highly reputed agency here in Europe. So in a sense, that validates the technology that we are using. Because of this award, we will be invited to attend the Global Space Congress in Abu Dhabi next year, May next year. We will go with the European Space Agency in order to attend the meeting. And here I will show the solution, right? How it works. It's a very short video, but I would like to translate all these theoretical concepts and theoretical approach into real information. So a short video of how it works. So here we have a dashboard, so a short presentation of statistics that provide a synoptic view of what is happening in your area of interest. And here you can see the browser of events. In this case, event translate into oil spills that we have detected in several parts of the world. So for instance, here we are seeing an oil spill in the coast of Fujairah in United Arab Emirates, detected, I think, summer this year, yeah, 28th of June. So the nice thing about here is that we are using an optical satellite, and that helps us understand where is the thick oil. The thick oil means the oil that is more dangerous for human persons, but also for the ecosystem as well. So it's the first oil that we have to clean, that we have to retrieve. Here, what we are seeing is a discharge from a ship, right? So another use of our platform is to detect illegal discharge of oil from ships. That I was saying, it's unfortunately a very common practice. So as you see, here we are manipulating some icons of the platform to select and deselect. We have to be intuitive, so a child could understand how it works. Here you can see another example of an oil spill detected in the Red Sea. It's close to Egypt, if I'm not wrong. So again, the satellite helped us detect this event from the sky, from the space, and we can also characterize the event. We can understand not only the position in the area, but also understand if there is thick oil and where is it, and also to quantify the spill. And this is the last example that we have. This is a case of an unfortunate attack to an oil tanker, again in the United Arab Emirates last year, I think. So the ship started leaking oil in front of the shoreline, and we were required by some authorities in order to help in providing information. So that would be an example of how the tool works. Some, let's say, interesting information about how this helps our customers. First of all, as we use open source data and automation, we can reduce the cost of monitoring by a factor of 10. As we have a very exclusive experience working for the Spanish Coast Guard, we can increase the accuracy by around 70%, and also provide very crucial insights for responders, like is it really mineral oil, what we have detected, or for instance, understand the thickness of the oil and quantification as well. If there is a source linked to the oil spill, we can identify the source, for instance, ships. It has been designed to be really user-friendly and easy to use, so you don't have really to be an expert in geospatial software or in marine pollution. So if you're a normal user, you can understand the information very easily. And we have partnered with an Italian company in order to understand also the future of the oil spill. So what is going to happen in the future, in the near future? Where is it going to move? Is the shoreline going to be affected? If the shoreline is going to be affected when? In 12 hours, in 2 days, in 2 hours? So we are integrating forecasting as well. So I would explain a little bit about artificial intelligence, about how we use artificial intelligence for this task. The field of artificial intelligence that we use is called pattern recognition. If you can identify the background of this slide, it's from the movie Matrix, right? So this is a very funny thing. I really was surprised about the fact that these letters in the background are in reality sushi recipes. So that is really, really funny for me. So something about science fiction, it's really telling us about how to teach, how to prepare sushi recipes. So this guy that I'm showing here, it's Edward de Bono. Edward de Bono is a leading figure in the study of the brain and also creativity. I would suggest to read one of these of his books. It's really amazing how this person contributed to understanding how our brain works. And he described it that the brain works creating patterns and using those patterns to understand reality. So in a sense, when we use artificial intelligence, we're trying to replicate this system, right? Our brain takes information as an input, creates a pattern with the input, and then it derives an output. We call this process learning, right? So when we try to use artificial intelligence, we use the same approach. We give to a machine, to a computer, a lot of inputs, a lot of information, data. In this application, it would be satellite images of oil spills, and they create a pattern, an algorithm that translates that into an output. As I was saying, understanding what is an oil spill in a satellite image is something that is not easy at all. It's kind of tricky. So it's a field of artificial intelligence that we call expert-driven AI. This professor, Sebastian Thrun, is a leading figure in artificial intelligence from the United States. They developed an algorithm that can identify skin cancer using mobile devices. So that would be when it's released in the market and operational. It's going to be a huge improvement in the health of societies and the health of population. We are not trying here to eliminate doctors. What we are trying to do is to democratize the access of this kind of information. So anybody in the world can have this very accurate information. Of course, the last, let's say, the last opinion is the opinion of a doctor. But this helps a lot in the process. So we can provide a very fast and very accurate diagnosis. So some other applications, as I explained, we are highly focused on the maritime domain because of our background, because of our experience, but we are delivering other kind of applications. We have an app called SAMS that translates into Shoreline Automatic Monitoring System that aims at helping countries and understand coastal erosion. As you know, global warming is causing a lot of damage to the coastline of our continents, of our countries. So it is very important to understand how this process works, how the coastline evolves. So we're taking images of the coastline on a daily basis, and we have an algorithm that detects where the shoreline is. So we can make a very accurate diagnosis of how the coastline is evolving. Some other applications that we are also developing for some of our clients is disaster monitoring. Satellites are a very, very nice tool to understand changes on the surface of the Earth. So here I'm showing an example of floods that we have here in Valencia last year, and it caused a lot of damage in agriculture and also in some other infrastructure. So it was interesting to understand the level of the water in this internal lagoon. Okay, another application that is very important for some industries is to monitor infrastructures. So I can understand if there is a potential risk. This is a very common example that we are asked is to monitor dams. As you know, dams are subject to high pressure because of the water they are supporting. So there's a risk of crisis here. You know, if the dam breaks, then we can have a very, very potential risk there. So using satellites, we can understand with millimetric accuracy how the dam is deforming, how the structure of the dam is deforming horizontally. Okay, so that would be a summary of our activities. I would like to share with you also some reflections about the future. From Orbital EOS, we think that the future is going to be very smart, which is a kind of very, very interesting. Instead of using artificial intelligence here on the ground and analyzing imagery with artificial intelligence here on the ground, we will put that machine, that intelligence into satellites. So the satellites will take decisions for us. It would be much faster and cost efficient. It would be in real time. So we will have information very, very fast coming down to Earth from satellites. And hopefully it will be accessible to anyone. So maybe it's funny, but I'm totally convinced that in 4 or 5 years, we can do a selfie using a satellite from a mobile device. That will be feasible. So I'd like to say also that all these things will happen if, of course, we behave ethically and we take care of the planet that we call home. So thank you very much for your attention. I hope you enjoyed my presentation, and I'll be glad to answer your questions.
Thank you so much, Juan. That was like mind blowing. I could watch those over and over and over again just to see how like the work that you guys do, and then also the other technology that's available. I mean, that AI is so advanced that we can possibly detect skin cancer is just crazy. So I've got a million questions, but I'll leave it open to everyone else first to ask. We had Abdullah really quickly stick up his hand. So if you want to ask a question, please go for it.
Yeah. First of all, thank you, Juan, for this amazing presentation and such an amazing project. I spent a few hours this morning just looking at it and reading about it. So my first question is, in your mission, you mentioned that you want to democratize access to satellite-based maritime intelligence. Does this mean that in the next few years, we'll all have access to your data for free?
I hope so. Well, I mean, what we're trying to do now, of course, you can guess that this goes in steps, right? It can go from one day to another, but the access to this information was hugely expensive. It's expensive. So what we're do is to transform something that is very, very complex and very expensive into something that is easy to use and affordable. Currently, we are delivering this information to companies and organizations, but we are totally open, and we will be very, very happy to, let's say, open the information to the public as well. Yeah.
If I can have a follow-up on that.
Yeah.
I also wanted to ask. So this is a question for all of us who don't have a technical background in how life works. So basically, do you get to see the whole globe at all time, or just half of it, and then you wait until it turns around?
Yeah, it would be the second one. So we are using what we call satellites with polar orbit. So that means that as you can understand, the satellite circles Earth, and it's passing over the pole in every orbit. So we are seeing the poles in every orbit, but the rest of the world we are not seeing in every orbit, right? So we have to wait until the satellite passes over Saudi Arabia to get the image, right? We could do that. We could see the whole picture, the whole globe. If we put the satellite so far, that means 36,000 kilometers, that the satellite moves at the same speed as the Earth, right? Then we are seeing the whole Earth, the whole globe. Well, we would be seeing half the Earth, right? The face that we have facing the sensor. The challenge here is that they are so far from the Earth that the level of detail, what we call spatial resolution, it's about 1 kilometer. So for certain applications, for instance, understanding when you see the weather forecast in TV, this is the kind of satellites that we use for that. But you can see clouds and you can see many things, but normally the geographical scales is in scale of countries or continents. We cannot detect oil spills, for instance.
If you guys don't mind, one question.
Yeah, of course.
Okay, so for us who watch a lot of scientific movies, we've came to know that basically Earth is like a magnet to light. Doesn't that mean that if you position the satellite far enough or in a far enough angle, the light, which is in this way would be sight, would mean that you can see behind the globe?
I don't know if I really understand your question.
Well, I don't know if I understand my question. It's fine. Feel free to ignore it. Thank you for your time, Juan.
Okay, nice to meet you. You're welcome.
Thanks, Abdullah. Great. I think Mahmoud put his hand up. Could have called that.
Thank you, Laura. Thank you for the presentation. Very interesting concepts. I really like aerospace technology and how we're using it to solve Earth problems. My question is regarding the material cost and why is space technology so expensive, and what can we do to reduce the cost of space technology? Is there something like playing with the materials, or what is the general trend that's happening today to solve that problem?
Okay. Thank you, Mahmoud. This is a very, very interesting question, actually. So I would say that we are currently living a very, very interesting decade in that sense. The cost of a satellite has been reduced by, I think, a factor of 1,000 now. So yeah, from in 10 years, I think, yeah. So in the past, only NASA and the European Space Agency could build and launch a satellite. Now you have companies, very small companies, startups, building and launching satellites. The main challenge is the launch. The launch is very expensive, very, very expensive. Each kilogram of satellite costs many thousands of euros because of the fuel that you have to put inside the rocket. So that would be one main challenge for the space operators, satellite operators. The cost of the satellite is not so high now. You can build a small satellite, shoebox size. So you have now even universities building satellites, right? With a moderate budget. The tricky thing is if you want to launch it, then you need money, a lot of money. That's the tricky thing.
Do you think SpaceX has contributed to this conversation in any way? Because I know that they have done something that no one else have done before, which is like that launch issue, I think, right?
Yeah, absolutely, absolutely. Well, first of all, for me, the first milestone is that a private company is putting things into space, astronauts, and that was impossible in the past. Impossible. No private company can do that. Now NASA is giving all the contracts to SpaceX to put satellites in orbit rather than doing it themselves. That is huge. So yeah, Elon Musk, in that sense, he has this vision as well, I think, of democratizing the access of technology to everybody.
Thank you. That was very insightful.
Thank you very much, Mahmoud. We have a question from Ahmed.
Hello, Juan. Thank you so much for your interesting presentation. I'm a huge fan of watching documentaries around cosmology and the nature here on Earth. My question is, so you've talked about oil leaks, either from accidents, illegal oil leaks, or maybe station leaks. Well, my question is, when there is a leak, does your company provide a solution to reverse that damage to the ocean? If yes, what is the solution, and if not, what is the possible solution to minimize that impact? Thank you.
Okay, thank you very much. It's a very interesting question. So I would say yes and no. Well, what we provide is information. So that is the first of the response. We have been involved in crisis in the past, working for the for the Coast Guard. So you can have the best response teams, the best ships, the best whatever. But if you don't have accurate information, it's going to be very, very difficult for you to efficiently respond to anything, because everything becomes a mess. You don't understand really what is happening at the ocean. At the ocean, it's a very dynamic environment. It's changing all the time. It's not like land, right? You have a spill in land, it doesn't move, right? But in the ocean, it's moving all the time. So we don't respond to the pollution that is the work of what they call the oil spill response industry. Companies specialized in responding to oil pollution when it happens. They have chemical substances that dissolve the oil. They can also put barriers. So they try to minimize the impact. The first thing that they try to do is that the oil doesn't reach the coastline. This is the most important thing. If the oil reaches the coastline, the impact multiplies by a factor of between 10 and 100. Because wow. Everything that is, impregnated in oil then becomes waste. If we have sand with oil, that becomes waste. If we have stones in the beach that are impregnated in oil, we have to remove that as well, because it's toxic. So I don't know if I answered your question. We don't try to overlap with other part of the supply chain, which is the actual response to the pollution. We cannot do that. What we can do is to provide fast and accurate information.
Yes, thank you so much, Juan.
You're welcome.
Thank you. Thank you very much, Ahmed. We have a question from Milan. Go ahead.
Thanks, Shai. I had to put the hand up so to wait in the queues. Juan, I know everyone asking about technical question. One of the questions we wanted to ask about the getting into the industry. So we have trainees from various industry, engineering to English major to marketing. One of the people think, okay, if you need to get into space industry or anything related to AI, you need to study, you need to be an engineer, or you need to be have a certain degree discipline to get in there. I personally think that's not the case, but I just wanted to get your thoughts on this. What do you think on getting into the industry? And do you need to have specific skill, specific degree discipline?
You mean to work in space industry?
Anything to do with the space technology.
Okay, that is a very nice question, actually. So I would say that the first thing that you need is passion for what you do, right? Then the rest goes, easily. If you want to become a space engineer, you just learn, right? You just study, you go do a master, go to the university, whatever. If that is what you like in life, then it's easy, you learn things that you're passionate about. So it's so easy. Actually, that is proved as well by neurologists. The speed that in which the brain understands the world and understands and learns is much faster when there are neurotoxins that indicate, joy. For instance, when I am enjoying, for instance, I'm having fun now. This is a very interesting situation for me. The likelihood of me learning things from this interview, it's much higher than if it were boring for me. So from my own, let's say, perspective, I wouldn't focus so much on degrees. I'm not the only one who says that. Okay, also Steve Jobs says that. So I wouldn't. Okay, have degrees is relevant, is important. Have technical background is important to understand. The first thing you have to choose is what you like to be. What is your passion, and what is the problem that you want to solve, right? So the advice that I would give you also is do not start with the solution. If I like blockchain and I want to solve any problem with blockchain, that is a very inefficient way of doing things. I would try to look for a problem that reflects my sensitivity, a problem which is familiar to me and I understand, or maybe I suffer this problem. Then I use the technology, whatever technology, to solve the problem. I would say, it's just my opinion.
You are muted, Niran.
No, I like the answer. First find the problem, then solve, then find whatever the way to solve the problem. Right. Great. Thank you, Juan. Just Abdullah.
Yeah. Sorry. Thank you. Just one comment. So, well, I'm an entrepreneur. You many times find companies, struggling. Actually, we struggle as well. Struggling to find your place in the market and trying to convince your customers this is a very good product and so on. First thing you have to understand is their problem. You have to deeply understand, can I help these people? Can I solve this problem? Because if you don't deeply understand that, then you're not going to be successful. So don't become a solution in search of a problem. It's the opposite.
Thank you, Juan.
Thank you.
Abdullah.
Thank you, Niran. Yeah, Abdullah, go ahead, please.
Oh, sorry about that. So my question is, if we assume that satellites are going to be defective in I don't know, 200 years, 100 years, I don't know, what are you going to do in that case? Are you going to send someone to fix it, or are you going to get it back? And how to do that environmentally friendly?
Very good question, Abdullah.
Okay. Very well. So engineering design in satellites is advancing a lot. That is also about the environmental impact of space technology. That is also on the table for the industry, for the European Space Agency, for NASA. So there are already companies that are working on what they call deorbiting technologies. So what normally happens is that when the satellite stops working, you have designed it to put it in an orbit that it's called cemetery orbit. So it orbits there forever. Or you put it in an orbit that goes down to Earth, but in a way that the satellite disintegrates, right? Breaks down in very, very small pieces, dust, right? These are the two main technologies to remove the satellite from an operational orbit. But there are many advances in the field which are very interesting, like satellites that collect rubbish, that collect pieces of other satellites. There are some companies working in that direction. And it's very interesting because it's a challenge as well. It's a challenge. So I answered your question, Abdullah?
Oh, yes, you did. Thank you.
Thank you.
Thank you very much. Yeah, please.
If I can just jump in there, I think that was a really important point and question raised by Niran, and I just want to reiterate it again. And thank you, Juan, for mentioning that, because I think I'm so glad that you emphasized passion and that there's also scientific evidence behind the way that we absorb information with regards to whether we have an interest in a field, because I think a lot of the problem these days, or just general in human nature, it's so easy to think that we're inadequate for something or we don't have the skills or the knowledge, but it really just comes down to the passion and the amount of effort that you want to put into something, and then also looking at problems and not like starting with a solution. I mean, you can say I want to solve world hunger, but that already limits you to the way that you think. Rather, look at something and think, what are the causes? Why we face certain issues, and then build from that way. It's kind of like deconstructing a problem, and it's kind of taking the process reverse. And I think that's super important, especially with this program. I think I would also be worried if I didn't have the necessary skills to be put in a project that wasn't in my field. But it's all about sort of what you want to do and how you want to do it, and then you can build yourself from there on. You don't have to be from a science background working on, it's more about how you want to do things and what you want to do. And I think that's a really important sort of thing to take away from that. No, Niran, you can't ask a question.
Someone else. That's the question?
No, I'm joking. I'm joking. You go for it.
Yeah. I just wanted to ask you on in terms of like, let's say you're an employer as well, you're an entrepreneur and an employer. So when you hire someone for Orbital EOS, what do you see in, I know you mentioned passion, but apart from that, what do you see in a candidate when someone will say, hey, I want to work with you, can I give me a job or something like that? What is that like, say, you might get 100 applications, 200 applications. What makes you think, okay, this is the candidate, this is the person I wanted to work with? As an employer point of view, just wanted to pick your brain on that.
Great. Okay, thanks. So I would say, yeah, that is, that is evolving all the time. When we interview people, we are learning as well. So first of all, we put ourselves in the position of, first of all, trying to be very, very fair with every people. So we try to avoid bias in our judgment, whether it's, whatever kind of bias that we may have, cultural or yeah, whatever, origin of the person, whatever. We try to put ourselves in a very objective position. Yeah, but coming back to the most important things that I think for my company, attitude would be first one, and passion and attitude, and then the technical stuff. Of course, the technical stuff is important, but passion and attitude is the first one that is needed for problem solving. We have to be a company that works well in innovation. Innovation is very hard because you're trying to solve problems in a different way, or you're trying to solve problems that have never been solved. And we're not trained for that. We're not really trained for that. So you have to try to think differently. You have to be passionate about solving problems. And that is not very common in people. I would like it to be very common, yeah, but that's not very common in people. So we try to choose people that live comfortable outside of the comfort zone. Yeah. So we try people who is, brave, who is passionate, who has an attitude of constant learning, who like uncertainty and so on. That is a very, very different. Very different approach from a very big company, It's a very different approach. We need heroes.
And I completely agree with the point that you said about innovative and so handling problems. Sometimes you don't even know the answer because this is the first time you are, right? Even in with us as TCC and consulting, because some of the clients come to us, that solution is not exist out there. They're like, we are there to partner with them to solve that problem. So in that case, we don't even know what is the answer to this problem. So we are kind of exploring, right? What can we do because there's no solution available out there. So it's quite interesting, what you said. It's really important that people should be open to the idea of trying and failing, and then trying again. So that's it. True. Thank you, Juan.
Yeah, absolutely.
Thank you, Nilan. And that's why I think the consultants get paid too much, because they are thinking and coming with innovative ideas to solve problems.
But it's more like working with the clients, right? Because that's why we tell that we don't know more than us, and we are a partner for our clients, and then how we can work with them to solve the problem, because without them we can't solve the problem. So it's like everyone come together and working and solving that problem. So that's a major. But
yeah, absolutely. This debate is amazing for me. Talking about innovation, it's very, very interesting. Einstein used to say, you cannot solve a problem from the same place the problem was created. So you have to put your mind in another place to solve the problem. Otherwise, you're not solving it.
Yeah, exactly. And I think we have to use two different techniques in solving problems. One is forward thinking and inverse thinking. So that we can utilize all of our ideas to solve problems. Okay, thank you, Niran. We have a question from Mahmoud.
Thank you, Mshara. I was just going to ask, do you think innovation can be learned? Or is it something that's inherent in the person?
I think innovation can be learned. Yeah, I think so. Well, I'm not an expert in innovation, right? I try to put innovation in place in reality. I wouldn't say this is all personal opinions, right? But I think innovation can be learned and innovation can be taught. There are many books that explain things like it's not so much about learning new things. It's very much about unlearning what you have learned, right? Because when you try to innovate, as we were saying, you cannot solve anything with the same patterns that you have in your brain, like what I was explaining, right? You have the same patterns. Unfortunately, your brain is an automatic machine. So you're thinking in the same way you have learned, and you're using the same patterns all the time. So you have to switch your brain to put your brain in another place. So there are techniques to do that. There are techniques. I would recommend you to follow Edward de Bono books, to read them. There are some very, very interesting books. He's the father of the concept of parallel thinking. Parallel thinking means, we are approaching the problem from a very new, different perspective. So what we're doing there is repatterning. We are creating new patterns. That is where we find a solution for a problem, when we create a new pattern.
Very interesting. Thank you very much.
Thank you so much. Thank you, Mahmoud. Thank you, Juan. We have, yeah, please, Niran.
We can take the last question, right?
Yeah,
Sorry.
exactly. Yeah. So Noreen will be our last question. Okay, go ahead, Noreen.
Hi, hear me?
Yeah.
Okay, do you mind giving advices and tips for someone who's considering doing a business into space industry?
Sorry, I didn't really understand the question.
Recently, I've been thinking of start a business related to space industry, but I don't know actually how to start, and I just want some advices and tips if you don't mind.
Okay, sure. Where to start? Well, yeah, as I was explaining you, I think a good start point is to look for a problem that you think that could be solved using space technology. But first of all, you have to deeply understand the problem, deeply. You have to immerse yourself in the problem. It could be global warming, it could be floods, it could be, I don't know, agriculture, for instance. There's a lot of scientific background in using space technology for that. Or maybe you can build satellites, or you can build launchers, or you want to become an astronaut. I don't know. But the first thing I would suggest is to reflect deeply about what kind of problem I would like to solve. Yeah. And then look for a friend that shares your passion, and just start doing things. The rest, the world will help you. That is how we started, actually. It was we shared the idea in the swimming pool of a friend, and why don't we start thinking about this idea, and now we're a company, really. I don't know if I helped you. Yes?
Yeah, you did. Thank you. But I was thinking, what's the most challenge you faced in the beginning?
Okay, the most challenging thing. Okay, when you start a company, there are things that you know, and there are many things that you don't know at all. There's a lot of uncertainty there. For instance, we are a company formed by people with technical background. So when we started, we knew nothing about business, nothing at all. It was the first time that we launched a company. So it was a bit hard to position that we were able to sell something, that we were able to explain to our potential customers what we were doing and how we could help them. But as I said, you have to put yourself in a position of constant learning. You are learning all the time. And this wasn't so advantageous in the past, because the past, the world didn't change so much. But in the present, that we are producing so much data on a daily basis, that the world changes very fast, very fast. So you have, Airbnb, well, not now, but 5 years ago, Airbnb disrupting the whole touristic sector, or Uber disrupting the taxi sector. So you have to be learning all the time. I see that as a very good thing. But you have to put yourself, it can be challenging, very challenging to learn about many things, because if you build your own company, you have to learn a lot of things, but once you put yourself in that position, then you just start walking, and things happen.
Thank you so much. That was really helpful.
Thank you.
On the final note, thank you for your time. And just one thing I wanted to ask: what is the one thing would you tell all this audience today here, or the trainee consultant? What is the one thing that they can take away? Or I'm sure there are so many things they have to take away. But what is the one you would give it to them?
I guess that there's so many people here with different backgrounds, different dreams, different passions, and expectations in life. My main advice is to try to find something that you love, and just follow. Just follow, because that's the way to happiness. In the past, we did to do jobs that we didn't like to have money to live, but things are changing now, and that is totally feasible now. It's the first moment in history that a person with 20 years old can become a billionaire. We can see this in TV, right? It's the first moment in history. A group of guys with an idea become Facebook, or become Uber, or become so. There's a lot of passion there. Otherwise, it couldn't be possible. There's a lot of knowing new things, doing new stuff, and the accessibility of technology plays a huge role here as well. So I found myself in the past doing things that I didn't love, and I regret. So in the future, as a team, we also try to engage only in projects that tell us something, that gives us something, that try to enjoy it every time.
Okay. Okay, great. Okay, well, thank you so much, Juan, and I don't think Pablo's still on the call anymore, but yeah, thank you so much for your time. I think it was a super interesting conversation to see the technology that you guys use, but then also the inspiration behind your technology. I think really very awe-inspiring and inspirational for everyone. So yeah, thank you for your time, and this call will be available to anyone who wasn't here. So thank you to everyone else who attended the call for your questions. And yeah, awesome. Thank you to everyone.
Okay.
Thank you.
Thank you very much. Really pleasure. If anyone wants to reach me for further questions, I'll be totally available to anyone. So you'll be provided my email. So happy to have your comments, questions, whatever. Thank you very much.
Thank you. That's really kind of you.
Thanks for your time, and speak to you soon.
Thank you, everyone.
Okay.
Bye.
Bye-bye.